remove this dot, so it is j b dot cos theta, and the value of this mu j is equal to uh, eg over 2n into j. Okay, where theta is the angle between the mu j and b naught, that is j and b naught. Now since this cos theta, it is equal to z component of j over j. Okay, that is written. After that, the value of this z component of j, it can be written as mj into h cross. Let us designate this equation number 7. Now substitute these values, of cos theta, which is equal to j z over z. We also substitute the value of jz in this equation number 6. On solving, we got delta E, it is equal to G mu B B naught mj. So the energy can be written as E naught plus delta E, which is equal to E naught plus G mu B B naught mj. In the lateral case, in the normal Zeeman effect, this energy is equal to E naught mu B B naught ml. Here the factor is, additional factor is G, and in the place of here this factor is additional, and at the place of ml we have mg. So this is the energy. Okay, so next is, now we know the quantum number mj. You can take the value 2j plus 1 as the previous case in which we saw the values of ml. It is, these are equal to ml plus 2. So here the values, the number of values are 2j plus 1, and the values are value range from minus j to plus j. So if mj has 2j plus 1 values, so similarly as it is related with energy, so energy have 2j plus 1 values. So let us try to donate the initial and final labels by single and double primes. Okay, so whenever we will write the energies with the single prime here, energy, we know the energy equation, E is equal to E naught plus G mu B B naught mj. So for the initial label, it is shown with the single prime, and for the final state, it is shown with the double prime. So this, we also know the selection rules for the same, which are very important. Selection rules are very important in every case. So delta mj is equal to 0 or plus minus 1. This is very important. mj 0 to 0, here delta mj becomes 0, but this transition is not allowed in a case where we observe that delta j, it is equal to 0. Okay, so remember this factor. Now after that, we take the difference of this E prime and E double prime and divide by h to calculate the frequency. So whenever we will substitute these values, this whole expression reduced to the formula mu, it is equal to mu naught plus mu b. Mu b is the Bohr magnetron, mu naught over h bracket g dash mj prime minus g double prime mj double prime. So this reduced to this frequency. So this is the anomalous Zeeman effect, and the frequency formula is given by this formula, that equation number 2. Is that clear? I hope all this discussion will be helpful to you. And if you have any question, you can ask me. So if you would like to calculate the Linde factor, so let us do the exercise to calculate the Linde G factor. This is a very important question even in UGC net examination. Number of times this type of questions are asked. So let us try to evaluate the Linde G factor for pure orbital angular momentum, यानी कि for an atom which have pure angular momentum. Second part is for the atom having pure spin angular momentum, and for the state P13, that is the third part. So let us try to solve the first one. Now, we know that for pure orbital momentum, as it is equal to zero, because now we have pure orbital momentum. That means L, it is not equal to zero, and as it is pure orbital momentum means its S is equal to zero. So from LS coupling, we know J is equal to L plus S. We put the value of S, it is equal to zero, so that reduces to L. यानी कि J जो आपका है, that become equal to L. So then use the formula for the Linde factor. G, it is equal to J 1 plus j into j plus 1, this formula. Okay, so now in this formula, what we do, we will substitute the different values. We're going to fill this value j, it is equal to L at that place. J, L, here j, that is L plus 1, and at the place of S, we put 0, 0 because S, it is equal to 0 in this case, and this remains same. We saw this L into L plus 1 that get cancelled with this. So this becomes 0 over 2L into L plus 1, that is 0. That means 1 plus 0, which is equal to 1. That means for an atom having pure orbital angular momentum, its G factor is equal to 1. Is that clear? For the second part, the atom in this case the atom has pure spin angular momentum. That means its L, it is equal to 0. So once again we will use the formula J is equal to L plus S. Substitute L, it is equal to 0 here. J become equal to S. Okay. So then use this formula again, where the place of J substitute S, and in the place of L, J, we are going to substitute the J as S, S here, this remains same, and for L, 0 and 0 are replaced. So this S into S plus 1 plus S into S plus 1 minus 0. So that become twice 2S into S plus 1 over 2S into S plus 1. That get cancelled. That become 1. So 1 plus 1 become a 2. So here we got G is equal to 2. So we also come to know about the conclusion that G is different for different states. Okay, here G is equal to 1 for an atom having pure orbital angular momentum. For spin angular momentum, only the value of G, it is equal to 2. Now we are going to calculate the third part, in which we will see the state P13. We are going to calculate the G factor for the state P13. So let us try to calculate that. First of all, there is a need to understand the spectroscopic terms. Okay? So this one subscript, this is the value of J, that represent the J value. So we know that subscripts are J. So this one, it is equal to J. and this 3 supersubscript, that represents the multiplicity, that is equal to 2s plus 1, which is equal to 3 here square. On solving this, you will get s it is equal to 1. As it is in the p state, so for the p state, the value of L it is equal to 1. If we have S state, L is 0. If we have P state, L it is equal to 1. For D state, we have L it is equal to 0. Now we will substitute the values of J is equal to 1, S it is equal to 1, and L it is equal to 1 in the G factor formula. So the formula is written again. This is the formula. Here we substitute the value J, J11, S11, L11 over J11. So on solving, we got the value of G in this case comes out to be 3 by 2. Again, we conclude here that for different states, the value of the Linde G factor is different. Okay, I hope uh, you get the elaborate. I hope you understand this exercise very well. Okay.